Let's take a look at Reflector. It's a tool for debugging and understanding third-party code, or just any code that you have to work with compiled, so frameworks, components, libraries, or even legacy code. It comes as a desktop application that lets you look at third-party code statically, and also as a Visual Studio extension that lets you debug into third-party code as though you actually had the source code to work with yourself. I'll show you a quick overview using both of those, and then highlight some of the most useful Reflector features. So we'll start with this test app, which is quite a simple WinForms app. Takes a number, checks to see if it's a prime of a certain size, and then writes the results out to a file. That's not particularly useful. It's also not particularly stable, as we'll see when we try to run it. So if you just stick in a value, and that crashes with what we then see is an index out of bounds exception. So there's obviously something wrong with one of the arrays that we're using here. Now, there's a couple of ways we could start debugging this. We could decompile it and look around it with the Reflector desktop application, or we could debug it in Visual Studio and step through the code. Going to start in Visual Studio so we can get a feel for the workflow. So here we have Visual Studio. And to debug this normally, we would attach the run the debugger and attach the app. So I will just quickly do that. Okay, so we see the crash, but we don't see anything very useful in Visual Studio. So we would then break all, and we have the no source available message. Now, we can see a little bit more than this if we disable just my code. Here we see a call stack and a whole bunch of machine code, but it's not particularly useful. We are basically stuck here. So let's enable debugging with Reflector and we'll start again. Select all of the associated files, and what this is doing is decompiling the code and generating PDB files so we can actually step through the decompiled code as it runs. There we are, it's done there. So we can go to the Reflector menu and kick off a debugging session. So we'll give it some data to cause the exception. And we can actually see the code that's causing the exception. Here's where the index out of range exception is thrown. And we can see a much more useful call stack here, as well as all of the locals. Now, we've got a problem with this candidate variable here, which is part of iTest class increment. So we hop up to that, and we hit F12 to go to the definition. Again, this code is all generated by Reflector. Reflector shows us the code, so we can see that this is an interface, which again isn't massively helpful. So we can go back to the form control and look at where that interface is declared. So we go to the definition of the test class, and we can actually see some useful code. Now at this point we're in business. We can either read through this code and get a feel for what's going on, or we can go back and set some breakpoints and see what happens with the candidate variable. I'm just going to quickly show you that analysis with the breakpoints. Because Reflector has given us a PDB for this code, we can actually step into it and break it, which means that we can watch the locals change as the code runs. So we will set a breakpoint in this for loop here, and we will stop the debugging session and start again. Okay, the running code breaks and we can see the value for the candidate here. So hitting F5 lets us continue around that loop, and if we do that a couple of times we can see the value getting quite a lot bigger as we iterate. So eventually that's going to overflow the array here, and it looks like we've found our issue. So that's a pretty simple live debugging workflow in Visual Studio. But we could also use the Reflector desktop application to explore the code and get a feel for how it works. The desktop application has a few nice features I'll show you that make it easier to understand the third-party code. So, if we open up Reflector, and we will just drag in the XE. We can see it over in the Object Explorer here, and we can have a look into how that works. Now if you right-click on the XE and go to the entry point, we can look at how a user would actually start interacting with this code. So the first thing it does is open the form, and we can drill into that code. The form initiates the component, and that component gives us a field with a button and some other bits of user interface. Reading down, we see that things start happening with this start click here. And then we've eventually drilled down to code that's familiar from Visual Studio. We can now explore this a bit in Reflector. So, for instance, we can open the iTest class. And again we see, as we did before, that it's an interface. But from here it's easy to navigate to where that interface is implemented. So we go over to the tree view here and select the derived types. Reflector shows us which types implement the interface, so we can navigate quickly to where it's used, and then we can expand these methods. And again we're into that code that we were able to troubleshoot before. We've also got various navigation options here, so we can retrace that path with the back buttons. Or because we might want to hop about quite a bit, we've also got the option to bookmark things. You can get back to the bookmarks by pressing F2 or from the bookmarks menu up here. So from there we can just jump straight back into that code. Alternatively, to find things, you've got Search Facility, which you can access by pressing F3 or from the search option up here. So typing new test class will find that class for us again. See down there. We've got a few other analysis features in the desktop application, which you can bring up with the Analyzer button or by Control and R. This Analyzer pane lets us navigate through dependencies and see how the code is used. So we can see that the new test class depends on this class library here, and specifically on the iTest class, which we saw before. That in turn depends on various bits of MS-Corelib, obviously, and if we wanted to, we could navigate here into system.int32. We can also look at what else uses our iTest class. And again, we can see where that's implemented. So it's pretty simple to explore the code and understand the data and control flow of an application or a library. A few other things you can do as well. So at the top level here, we can export the assembly source code for our pSelector.exe or for any of the other classes. And up in the options menu, you can also enable something, the power commands feature, which are a set of small extra features that may help you save some time and provide some extra navigation options. So for example, that gives us a query facility. If we go back to the iTest class, we can at the class level run link queries from the Object Explorer here, and that'll let us list out things like fields and methods, exceptions, or where an interface is implemented. So again, that's another way of navigating to precisely how some of this functionality works. There's quite a few ways to navigate around the Decompile code and follow the data flow. So you can debug in the Visual Studio extension, and you can analyze statically with the desktop application. It supports the .NET framework all the way back to version 1 and the latest version .NET 4.5, which supports all of the new C#5 features. You can also look at code in C# as well as in Visual Basic. or in IL. The current version integrates with Visual Studio 2010 and 2012, and we're currently working on improving the analysis and debugging functionality in both the desktop and the Visual Studio versions. So that's it, a quick introduction to debugging and getting insight into code with .NET Reflector.